everyone. Hope I am audible. Okay. Yes, good afternoon. Okay. So, as I mentioned in the yesterday's class, today we will be looking the same finite state machine with the sequence detectors, which more deep inside it. Okay. So, today we will try to complete this and we will try to have an good understanding about the finite state machine. Okay. So uh, 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 these are the things which we have learned already. A sequence detector is a sequential digital circuits uh, that monitors a serial input bit streams and detects a predefined bit pattern. So when the desired sequence appears, the circuit assert an output. So whenever that sequence has get detected, we will be getting an uh, desired output. So suppose if we want to deduct 101 sequence, we can use 1101 also, we can use 010 also, we can use. So these are all used for detect the protocol header. Whenever we try to, someone is disturbing by raising the hand. I don't know why. If I see the same thing again, I will throw out from the webinar. Okay. It is not a warning or something like that. Okay. They started giving noise to the stuff. Okay. So don't do that. So whenever you try to attend, if you are not if you are not interested, please leave. That's all. No one is these everything is volunteer. Okay. So if you want to gain, if you already know, it is well and good, no problem, no need to attend, but don't disturb the classes. Okay. Simply don't go and press the hand button. I cannot give the permission to you guys to talk or something where you can go and give only the questions over there. Okay. So already I hope the syllabus and topics has been given to you guys. Okay. So from that only you would have selected the webinar. Okay. So please don't disturb the class. If you are not interested, you can leave, no problem. That is your interest. Okay. Okay, so now we will come to our thing. So this, see, we will be using some protocol to transmit and receive. Okay, so it will have certain rules. It will have some headers. So if particular pattern occurs, so how you will be able to detect? Those are our sequence detectors. Okay, and the communication frame synchronization, all those things comes from that. Okay. Video screen is visible and everything is visible. Okay. I hope you guys want to do it. Maybe I can again, let me share my screen. Okay. Now the screen is shared. Okay. So that means there is some problem with your end. Okay. So because I am using two monitors, in the live monitor I am able to see my screen is visible. Okay. So the sequence detectors are classic application of finite state machines. Okay. So nothing, we are revisiting the yesterday's topic. Yesterday we were being introduced to the finite state machine, and I have given you I have told you the examples of sequence detectors with the same thing. Today also we are going to the same thing, but we will try to understand, we will try to go deep and understand how that is working. Okay. So before that, let us try to understand why the sequence deduction is needed. See, a digital system must recognize ordered events. For example, there is a UART frame. We have an stop bit, data bits, and then parity bit, and then the stop bit. So it want to recognize this pattern. Likewise, SPI command recognitions. Okay, something whether it is in the mode 0 or mode 1, so such kind of things. And communication packet parsing, password and key sequence detection, protocol synchronization, error monitoring, digital control register. So there are many use cases for the sequence detection. So somehow you will be using that in your system. Suppose if I have a sequence something like this and I want to detect 101, okay, so the FSM check bits sequentially and asserts output when the pattern appears. Suppose during this time it will give 1, and then this also it gives 1, and if we consider the overlapping, here we have one sequence, and if we consider overlapping, this will take. If we are not considering overlap, this will not detect. That is the thing. Then this one, so you will get 1, 2, 3 and 4 for overlapping, and 1, 2, that's it, and 3. So 3 detection for non-overlapping and 4 detection for overlapping. So now you guys got an idea. Okay, so there will be, see, when we try to transmit something, when we try to receive, in between it is analog signals. But in the receiver part, we will convert that into a digital sequence. That is nothing but the ones and zeros. And that ones and zeros, whether we are getting it in a correct way or not, we want to detect. So that is where, so we have to detect some pattern. That is why they will go and put the header and the tail, and in between they will send the data. So if this is correct, then the rest will be the data, and this is the end of the data, so that the receiver can able to understand it. Okay, so these all are something around the communication part. Okay, so now in that you can have a overlapping, you can go and detect the overlapping pattern also and non-overlapping pattern also. So the FSM checks bits sequentially and asserts output when patterns appears. So whenever the pattern appears, it will go and give us the output. Otherwise the output will be 0. When that pattern occurs, we will get 1. So accordingly we can make our circuit and we can make our the decisions. Okay, so what is the basics of this sequence detector? It has one serial input. Okay, we have a serial input and clock, one reset, and output detect signal. So these are the, you can call it as component of the sequence detector. You can call this as a component of sequence detector. What is its behavior? It will read 1 bit per clock. So for one clock, it reads 1 bit. And for another clock, it reads 1 bit. So while reading the bit itself, it will change the state according to the bit. That is what you have to understand. Okay. And track partial matches. So that means how it is tracking the partial match. Yesterday I told S0, S1 and S2. If one has been deducted, it will shift to this. That means it is partial match. So something like that. Then assert output when full sequence matched. At the end of the state, 101 in CAM, it will put the output as 1. So whatever the thing we have seen yesterday, that I am trying to capture in the words and put it in the slide. That it's okay. So we will be trying to use through, we will be trying to build by using the flip-flops. So the combinational next state logic. Okay. So these are the things we will go on to use to build the sequence detectors. So each FSM state represents how much of the target sequence has been matched. So here, when we go with the finite state machine, okay, so we will be having a state. Okay, that state tells, okay, it is no match. But when it comes to another state, we can confirmly we can tell that it has deducted 1. And when it comes to the state 2, confirm we can tell that it has deducted 1 0. And when it comes to S3 state, it has been deducted the full sequence. Okay, so that is the thing which the finite state represents. Okay, so that means our sequence detector will revolve around these states only, depending on the input and how partially it has been get matched. For this pattern, I am talking about only for this pattern. You can try for another pattern and you can go and write it. Okay, that is different scenario, but I want you guys to familiar with one pattern so that you can go and do it by yourself by other patterns. So that is what the idea behind it. Okay, hope you got an idea. Okay, so before going into that, have you guys have any doubt in objective of today's lesson? See, from yesterday's things only I'm going to recall it with somewhat depth. Okay, so if I have any doubt, put it in the chat box. We can go and do the things. Okay, so now let me tell you at the first itself. Let me tell you. Okay, so suppose I have a sequence. Okay, I told 1 0 1 0 1 1 1 0 1 1 1 1. Okay, there is this sequence got deducted, and this one is got deducted, and this one is got deducted. If it is overlapping, means we want to check. See, these two things got overlapped. This one is got overlapped. Okay, that is where overlapping. Non-overlap, this one, that's it. Once it find, then again it will start from new pattern only. So it will not come, this will come. This is where non-overlapping. We have to understand. This I will put it in the slide. I will come there. Okay. So now what we are going to do is, first we will see it with overlapping. Then for the same thing, we will see it with non-overlapping sequences. With non-overlapping sequences. For the overlapping, we will try to put Moore machine. And for the non-overlapping, we will, for the overlapping, Moore machine and the Mealy machine. And for non-overlapping also, Moore and Mealy machine. So totally we are going to have 4 different analysis for this 101 sequence. That is going to be our next 45 minutes or 40 minutes of our full stuff. Okay, so this is what we are going to see it. Okay, so we are not going to change the pattern at all. We have to see only this pattern, and then with overlapping with Moore machine and then Mealy machine, and without overlapping with Moore machine and then the Mealy machine. So you will be getting an idea how it changes and how it goes, and all the thing we can go and look into it. Okay, so with that we will go and look. The first thing we are looking is overlapping. Okay, in that Moore sequence detector. Okay, so what is the meaning of Moore sequence detector? The output is depend only on the state. Please try to understand. The output is going to depend upon only on the state. That means for all state, output is determined, output is fixed. If it is in state 1, that output is fixed. If it is in state 2, that output is fixed. Okay, so now this and all I have captured everything in an, what I will tell, in an words. Okay, for detecting 101 sequence. So now we will come and revisit this after looking this diagram. Okay, after looking this diagram, we will come and revisit it. Okay, so always the starting point will come with S0. I told no, whenever it get reset, you need a starting point. So the starting point want to come to S0, and we are fixing. See, we want to deduct 101. We want to deduct 101, and our machine finite state machine will changes its state. Okay, will changes its state depending on the input. See, changes the state, it is depending on the input, but output you check, the state is fixed for the output. Okay, so that is the thing which you have to understand it. Okay, so now the same thing only we are trying to see the pattern. Okay, so now always the start will be happening it with, once it started, then it depends upon the thing. So all the state, okay, will be getting the inputs. That is okay. So the starting, suppose we want to deduct 101. If the starting is something, the starting will be with the S0 state, and we need 3 bits. We need 3 bits. But in the state 1, we will get only 1 bit. So we fixed the output as 0. So for this state, the output is fixed. That is why it is called Moore sequence. That is called its Moore, what we call Moore machine. Okay, that is called Moore machine, because for the state, output is fixed. For the state, output is fixed. For the state, output is fixed. Okay, hope you understand this point. Now, when the input is coming, it can be either 0 or 1. It can be either 0 or 1. Suppose if 0 is coming, that means we need a sequence which starts from 1, the second one is 0, and the third one is 1. But it is not meeting our criteria. Okay, so we are telling, if in the state 1, if the input is 0, let it be in the state 0 itself. Okay, in the state 0, if we get the input as 0, that means we are not getting our required pattern the first stage itself. So let it be here only. Okay, so this is what the thing. Suppose if we get 1, the input we are getting it as 1. Yes, we are, the first bit got deducted. So that means whenever the input is 1, it shift to the state 1. So when this machine move to the state 1, we already found that number 1 is deducted. We already found number 1 got deducted. Number 1 got deducted. So now the machine is in state 1 because number 1 got deducted. So in the reset state, if 0 is there, it will be in this state only. But when it goes to when 1 comes, the machine will change it to the S1 state. And there also output is 0, because we know that the input is 1. So we deducted 1, but we want to deduct 101. So it is not fully filled. So we maintain the output as 0 only. So now please try to understand. Now the machine will get input to the first state. This is 0th state. Now the sequence, you might getting the input 0 or 1, because the machine moved to the other state, and the input you will be receiving in this state only. Please try to understand. So whenever the machine changes to the S1 state, that means already 1 got deducted. So in this state, you will get either 0 or 1. If we get 1, then already 1 got deducted, but we need 0. But since it is 1, we will not change the state. We will be remain in this state only. Okay, in the state 1, if the input 1 we are getting, we will remain in this state only, but output is 0. Okay, now when the input is 0 in this state, okay, that means we have deducted the 2-bit. So now it is moving to the state 2. Now it is moving to the state 2. So when it reaches the state 2, 10-bit pattern, partially it has been deducted. Partially it has been deducted. Okay, that is the idea. It has been deducted it partially. Okay, so now the machine moved to S2 state, because in the S1 we received 0, so it went over here. Okay, now when it in the S2 state, that means 10 pattern has been recognized. Now the things comes, either you can get 0 or 1. The input can be either 0 or 1. Okay, so when the input is 0, okay, so already 10 is been received. Now if we get 0, then it is of no use. The pattern is not recognized. So we are moving it to S0 state. So we are moving it to S0 state. Then suppose instead of 0, if we getting 1, wow, the pattern has been chosen. So we are moving it to S3 state. And in the S3 state, always the output is 1. Whenever the machine comes to S3 state, the output is always 1. The output is going to be always 1. So when it reaches S3, that means 101 pattern has been recognized. Now you may have another inputs. It might be 0 or 1. That might be coming inside this. When the machine is in this state, it will come and get the stuffs. Okay, so when if it is 1 and we are looking for overlapping, that means we can jump to S1. We can jump to S1. Somewhere I made mistake, I think. Okay, so here it want to be 1. When the wait, here it is correct. Okay, so now we had already 101. Please try to understand. Okay, if the input is 0, first consider input as 0. When the input is 0, so previously it was 1, so we can overlap. Please try to understand. Okay, it can overlap, so it can move to S2 because we deducted 10 because of overlapping. And suppose instead of 0, if we get 1, that means it want to shift to 1. Sorry, here it want to become 1. So when the input is 1, it will move to S1 because 1 pattern got deducted, and then it goes and continues the steps. Okay, so this is the idea behind the steps, and here is the only modification I want to do is we have to make it as 1. Okay, that is a typographical error. Okay, so hope you guys able to understand this concept. Okay, hope you are able to understand this concept. So now with this understanding, if we move now, so state transition at the state as the S0 is 0, when you get input as 1, it is moved to S1. And when the S0, when we get input as 0, it will be in the S0 state. And when it reaches the S1, sequence 1 got deducted. So from S1, if the input is 0, if the input is 1, where it want to go? That is what it captured. Everything in the diagram that has been captured as like this. That is the idea behind it. Okay. So if you guys face any difficulty in understanding, please let me know. This is going to be the base for our future sessions. Our future sessions in the sense, for our melee machine, more machine, those things. We have to do only a small changes. Okay. So if you find any difficulty in understanding, please let me know. Okay. It is not that much easy, but at the same time, it is not that much difficult also. Okay. So only by drawing the things, you guys can able to understand the stuffs. Okay. So now, I hope, okay, we will go for the other thing. Okay. We are talking about overlapping only. So we will try to have melee machine. We will try to have melee machine. Okay. So in the melee machine, state, okay, and the input decides the output. Okay, the input, the state only not going to decide the output. The input also going to make the output. Okay, that is what you have to understand. Let us see the diagram, then we will come and look into it. So you see the state has been reduced. There we have 4 state, but here we have only 3 state. Okay, so those are the something which we will go and look into it. Okay, so now we will try to understand this. Okay, see, in the previous thing, the output is depend on the state, but you see here the output is depend on the state and the input. It is depend on the state and the input. That is where the melee sequence. Okay, we are going to deduct 101 sequence over here. Okay, so as usual, this is going to be the starting point. Okay, it is going to be the starting point. That is what we are going to get it. Okay, so you will get 1 bit at a time. So when the input is 0, when the input is 0 is coming, we want to deduct 101 sequence, but 1 is not there. So we will wait in this state and output also 0. Depending on the input, the output is changing. There, the state itself, the output is fixed. Here, depending on the input, output changes. That is where the melee sequence, that is where the melee machine. That is the difference between more machine and the melee machine. So when we get 0 for this state, when we get 0 as an input, and in this S0 state, okay, it will remain in the same state. The next state is also remaining in the same state, and the output is 0. Suppose if we are getting 1, that means our partial deduction got happened. So S0 is changing to S1 state when the input is 1. Okay, so from S0 state, it is moving to S1 state, but still the output, they are maintaining it as 0. Okay, still the output is maintained the 0. Okay, so depending on the input, again the output is changing. Okay, so this is what. So we received. So as usual, when we come to S1 state, we know that 1 got deducted. 1 got deducted. Now you will get the input to the machine because the machine is in this state. You don't think that you always get the input here, because now the machine changes the state. So whatever the input now getting, it will come to this only, because already the machine is in this S1 state. Okay, so many will think you will get input only in this S0. No, now the state is changed. Okay, you think this is the machine. This is the machine where you are giving the input, and the machine will receive the input at the particular state. That is what you have to understand. Okay, I hope slowly you guys able to understand it clearly. Okay. Okay, so here we received 1 got deducted. Now, if again 1 is getting as an input, that means the next sequence is 1. So that is not needed, because we need 101 and it want to be 0. So we are putting it as 1 and we are making the output also 0. And it will remain in this state only, because already 1 got deducted, and again 1 means, that means 1 got deducted. Suppose if the input is 0, that means our partial deduction happened. So it is jumping to S2 state, and we are maintaining the output also 0. And we are maintaining the output also 0. Okay. And the input is 0. So when it reaches here, we got this one got deducted. 1 0 got deducted. So now you will get input in this state. Okay. Because the machine is in this S2 state. Okay. Now the real thing comes. Okay. If our input is 0, that means it is not matching our pattern. So it is going to the S0 state, and always the we want to make the output. Okay. So since the pattern is not matched, I want to make this as 0. Sorry. Okay. This is what typographical error. The output is 0 because the input is 0. So it is not matching our part. So the output also want to be 0. Suppose instead of 0, if you are getting 1, yes, 1 0 1 got matched. The input is 1, 1 0 1 got matched. We are putting the output as 1. Now comes where we want to move, S1 state or S0 state. Since it is overlapping, 1 0 1 got deducted. Since it is overlapping, our first bit is 1. So it can move to S1 because 1 is already got deducted. Suppose if the next bit is also something like this, we can go and deduct. That's why it is moving to S1 state. That means while moving to the S1 state, output is 1. That means 1 0 1 got deducted. And then suppose if it is moving to S0 state from S2 state, the output is 0 because the sequence deducted is 1 0 0. Okay. So this is the thing you have to understand. Why it is moving to S1 state, in the sense it is overlapping, we are trying to check. Suppose if it is not overlapping, then we want to go and move to S0 state. Again we want to reset the machine, and we have to do that. That is the only change we have to go and do for making this to realizable. Okay. So hope you guys able to understand it. Okay. So here it is 0. Here the output is 0. Okay. So this is about the Mealy machine. So now if you look into it, in the S0 state is the reset state looking for 1. Okay. When the input is 0, output is 0, we are making it as in the same state. When the input 1, something 1 got deducted, we are moving into S0 state and we are making the output as 0. So now in the S1 state, we found 1. Now we want to look for 0. So when the input is 0, yes, it is looked, we are moving to S2, and again we are maintaining the output as 0. Okay. Now in the same state, when the input 1 comes, we are staying in the same state and we are maintaining the output as 0. Now in the S2 state, we found 1 0 1. I mean, we found 1 0 and we are looking for 1. If we get 1, we will send the output as 1 and we will move to S1. If it is 0, we will send the output as 0 and go to S0. So because of this, we are able to change the output depending on the input. No, we are able to reduce the state. But there, for each and every state, the output is fixed. So we cannot able to reduce the state. Somehow we want to use one more state because the output is not dependent on the input. It is dependent on only on which state it is present. Okay, so that is the difference which you guys want to understand. Okay, so you try to solve many problem regarding this, then you will be able to understand it in a better way. You guys will be able to understand it in a better way. Okay. So still now we looked into the overlapping. And what is non-overlapping deduction? Non-overlapping means After deduction, after it went to S3 state or S2 state, in which machine we got 101, no, that means it pattern got closed. Again we want to start from first. Again we want to start from first. We shouldn't go to the S1 or something. We want to reset and come. So we want to reset the finite state machine compulsory. If it is overlapping, that is not needed. But when it is non-overlapping, we want to reset the machine once we deducted the pattern. After pattern got deducted, we want to go and maintain that one. Okay, so that resets the thing, because it is not overlapping, because 101 for non-overlapping, once we got this, again we want to start from the first. So that means you will not get 2-1. You will be getting, for this only 1 you will getting, and next we will start playing it. For overlapping, okay, this one is correct, and again we want to maintain it, and this is also correct, it will get the output. So that is the difference between the overlapping and the non-overlapping steps. Okay, so deducted only first occurrence. Okay, after deducting 101, it again restarts from the S0. So these are the things which you have to keep in mind. So first you have to decide which machine you are going to use. Either you are going to use Moore machine or a Mealy machine, depending on your application. And then whether you have to check for overlapping or non-overlapping, overlapping or non-overlapping. Accordingly, you can go and design the things. So these all are some tips where you guys can go and look into it. Okay. So previously what all we did know, that is comes under the overlapping, and that is important in the communication protocols. Okay, so that is what the steps. Okay, in the non-overlapping deduction, the system completely resets after a match. Once the match happen, again it will start as a first, from the first, and it will go and do the things. That is the difference which you guys want to understand. You can understand only if you would have understand the previous steps. Okay, that is the idea. So for non-overlapping, for this you are getting 1. Sorry, for the overlapping you are getting 1, and for this also you are getting 1. For non-overlapping you are getting 1 only. For this part you are not getting the 1. That is the difference I am trying to give. So why I put these things again and again means, you guys, whenever you try to look into it, you will be getting it. So now we will try to look the same Moore machine with non-overlapping, how it behaves. Okay, first we will go and look into the this one. Okay, so now for the Moon machine, you see the output is fixed to the state. It is not depending on the input. That is the first thing you guys want to understand. Okay, so for all state, the thing is fixed. What is fixed? The output is fixed. Okay, now let us start. I want to deduct 101. Suppose in the start it will be here only, in the S0 state only. So now if we receive an 0, it will be remain in this state and output is 0. If we receive 1, it is jumping to S1 state. That means 1 got deducted, it is maintaining that one. And suppose here in this state, again, if you getting 1 as an input, it will be remaining in this state only, because already 1 got deducted, then again 1 came. It is not matching our pattern, so let it be here only. Suppose if the input is 0, it is matching partially, it is jumping to S2, and always this output is 0, and it is jumping to S2. So now 10 pattern got deducted. 10 pattern got deducted. Now here If we get, please try to understand, if the input is 0, we are getting it. Suppose if we are getting the input is 0, it is not matching our thing. We are jumping it to S0. We are jumping it to S0. Instead of 0, if we get 1, the input is 1, we are moving into S3 state. That means 101 pattern got deducted. 101 pattern got deducted and the output is 1. Okay. So now we want to reset it. Okay. Suppose if we are getting an 0, suppose if the input is getting 0 after this 1, if we are getting it 0, please try to understand, we are again moving it to S0 for restarting it. Okay. Then if we are getting 1, okay, 101, that means 1 got deducted, we are moving into S1 because we are starting from the first pattern. See, previously what we do, when we get 0, we will move to S2 state. That means 10 got deducted. Now it is not the case. We want to start it from the first when 0 comes. Okay. Now here, after that we got 1 means already 1 got deducted. Our first thing we want to get 1. So we can move it to the S1 state. So this is the twist in the non-overlapping. Okay. So hope you guys able to understand it. Okay. So this is the thing about the Moore non-overlapping. So now if you go and check, this, no, so the same thing I captured, whatever the thing I captured in the diagram, the same thing only repeatedly captured, and I have written it. Actually the diagram want to come first, this want to come second. Okay, no problem. Anyhow, hope you guys, you all are brilliant, so you can go and look into it. You can able to match whatever the thing it is happening. So you can see the difference between the Moore, the same Moore with overlapping. You can change the things. So everything comes under your design. So if you are able to make this design, then if it is a 4 state, you can assign the binary numbers for 0, 0, 1, 0 for this state, and you can have a state table. What is the input? What is the next state? And you can go and create, an expression, and then that Boolean expression you can go and convert it into an diagram. I mean the circuit diagram, and with that we can go and design our system. So this is the basic idea which you have to work. So at the bottom, our logic design comes over there. Our logical thinking, how we are going to think, how we are going to design with these tools. The tools, whatever I taught you, FSM, gateway, sequential circuit, all those things, how you are going to mix all the tools and you are going to implement to solve the problem, that comes through an experience. Okay. So you guys try to understand that. Okay. So now in the Mealy, now we have seen the Moore machines non-overlapping. In the Mealy machine, what is the non-overlapping? We will go and check by seeing the diagram. Mealy means, okay, the output is going to depend on the input also. So that is why. Okay. So we want to deduct 101. Okay. And non-overlapping. So as usual, when the bit comes, if the bit is 0, we need 1. So let us wait here only. So when the input is 0, output is also 0, and the state is 0 only. So it is coming to the next state is S0. When the present state is S0 and the current input is 0, the output is 0, and the next state is also S0. That is what the technically you can speak like that. Okay. So suppose we are getting 1. That means The input got 1. Wow, we got 1. We can change it to state 1. We can change it to state 1. So at the state 0, if we get input 1, output is 0, but the next state is S1. But the next state is S1. Once we reach here, we have been deducted. Number 1 being deducted. Number 1 has been got deducted. Yes, number 1 has been got deducted. Correct. No problem. Next, from here, from this state, when we get 1 as an input, whoa, here 1 got deducted, then again we getting 1 as an input, then no, we want to be in the same state and output is 0. Suppose we are getting 0 as an input, so we can change the state. Here S0, 10 got deducted, and here the output we are maintaining it here. When the state is changing from S1 to S2, the output is 0 because the input is also 0. So here we got 10. Now either you can get 0 or either you can get 1. How it is going to happen? Now we will look into it. Okay. When we get 0, again it want to start from the first. Yes, because we are moving it over here. When the input is 0, output is also 0. We are maintaining it. Suppose we are getting 1. Previously we moved to S1. Now no, we are moving to same S0 for resetting it, and we are making the, please try to understand, when the input is 1, the output is also 1, and again it is going to the S0. Actually you have to write one more diagram, but within this itself you can partition it. Okay, so somehow from S2 it is jumping to S0 state when any of the input comes. When if it is 1, the output is 1. When it is 0, the output is 0. That's the twist in the non-overlapping. Okay, if it is overlapping, if the input is 1, then we will jump to S1 so that we will overlap and we will go and check to it. Okay, so that is the idea behind this thing regarding the Moore machine, Moley machine, and then this is what I went and kept for the Mealy. Okay, once you guys able to understand the state, okay, so you can go and understand what is happening behind the, you can write whatever you know in words, you can capture and write it. Okay, so now you got an idea about Moore machine, Mealy machine, and in that overlap, non-overlap with the help of sequence deduction. So you can try your own problems and you can say, so sequence deduction is the best, a basic thing where you can go and understand the machines. Okay, you can go and understand the finite state machines. So you guys will be able to ready for higher complex topics. Okay, so with this, what are the practical examples of the sequence deductor? Where and all we will go and use these sequence deductors. I told already in the UART receiver, start bit, stop bit, and frame boundaries. For that we will go for the sequence deduction. SPI controller, chip select, command sequence, transfer completion. In the vending machine yesterday itself I was talking about the 5 rupee coins. I hope you remembered. And in the password lock, okay, and the traffic light controller. So where we will go and use this sequence deduction and FSM applications. Okay, so these all are something, the practical the things we will go and use it. Okay, so in the communication protocol applications, sequence deductions is used in the packet header recognitions, frame sync deduction, command decoding, bit stuffing deduction, protocol parser engines. In all these things we will go and look into it. And in the processor control applications, FSM based deduction used instruction decode. We want to decode the instructions. Okay, from the memory we will try to fetch it. After fetching, we want to decode it. How you are going to decode it? We want to detect the pattern. Okay, so that is very much important. Then in the interrupt sequence, which interrupt occurred, pipeline, exception handling, handshake protocols, and all these things we will go and use it. Okay, so whatever the things till now we learned is, this is the basic which we need, we will be using in design. Okay, so when it comes to the design part, you might be having a question, which machine I want to use, whether I want to use a Moore machine or a Mealy machine. If you want a stable output, go for Moore. And glitch sensitive system, you go for Moore. And simple verification needed, go for Moore. But for lower latency, fewer states preferred, resource optimization, go for the Mealy design. Okay, so how you need accordingly, you can design either by Mealy or Moore, that is your choice. But it's each machine has its own advantages and disadvantages. According to our requirement, we can go on to choose and we can make it. Okay, so the common design is, we will miss overlapping handling and reset behavior, incomplete state transition, latch inference, invalid state handling, wrong output timing, forgetting the default state assignment. All the things we will go and make a mistake. These are the common mistakes where we will go and do it while going and implementing these steps. Okay, so test cases we have to match. For each exact match, if there is a no match, if there is a partial match, overlapping match, repeated pattern, reset during deduction, and random input stream. So these are the things which we have to verify the strategies, how we can go and do the things. Okay, so in the VLSI, there is protocol controller, packet parser, communication hardware to control the FSM. These things we want to use these sequence detectors, processor interfaces, digital pattern recognitions. So for all these, we'll be using this sequence detectors. Okay, so in summary, we learned about Moore detector, Mealy detector, and in the mode of overlapping and in the non-overlapping. And applications, UART, SPI, protocol engines, vending machine, password lock, and traffic control steps. Okay, so these are the things where the today's session's summary. Okay, so hope you guys got an idea about what it has been happened. Okay, so this is what my today's session. Today because yesterday itself I have shown how to see the output using a Mealy machine, and now you can use the same deduction and you can go and get it, talk with your AI tool and try to get the code for Mealy, Moore with overlapping and without overlapping, and try to learn the things. Okay, so meanwhile, if you have any doubt, please put it in the chat. Let me go and download the PDF and put it in the group. So I hope I have, there was a small mistakes in the diagram. You can rectify it. Okay, I hope you guys can rectify it. I believe you guys are smart, so you can rectify that. Okay. So it has been done. Okay. So if you guys don't have any doubt, okay, no problem. We can meet tomorrow. Okay. what is the tomorrow thing? No. Okay. Tomorrow we will start it with the history of our hardware description language and all kind of things. Okay. So now tomorrow onwards we will try to go with the Verilog stuffs. Okay. So I hope you guys able to get an idea. Thank you. Yes, thank you all. Bye. See you tomorrow. Okay. Bye. Thank you all.